Hi, today we will learn about quadratic functions. So our objective is to represent a quadratic function using table of values, graph, and equation. Let us start with quadratic function using equation. For a quadratic equation, ax squared plus bx plus c is equal to 0 to be a quadratic function, simply replace 0 by y or f of x to form the quadratic function y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c. A quadratic function is a second-degree polynomial. Y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Let's have some examples of quadratic functions. First, we have f of x is equal to x squared plus 2x minus 1. Another example, we have f of x is equal to 2x plus 5x squared minus 9. It is a quadratic function but not written in standard form. Another example, we have y is equal to 3x times quantity negative x plus 2. This function is not in standard form, but if we apply distributive property to transform it in standard form, it will become y is equal to negative 3x squared plus 6x. Another example, we have a is equal to b squared minus 7b. This function is an incomplete function because there is no constant term, but there is the quadratic term, so it is a quadratic function. Let's have some examples of not quadratic functions. Y is equal to 7x plus 5. It is not a quadratic function because it has only linear term and not quadratic term. So the quadratic term is missing. Another example, we have f of x is equal to the absolute value of 2x. It is not a quadratic function because it has no quadratic term, ax squared. Another one, y is equal to 5x cubed minus 9. This is not a quadratic function because it is a third-degree polynomial. Okay, let's try this activity. State whether each of the following equation represents a quadratic function or not. Number 1, we have f of x is equal to 3x squared plus 4x plus 2. Yes, is it a quadratic function, or no, it is not a quadratic function? The answer is yes, it is a quadratic function because there is the quadratic term, the linear term, and the constant term. Number 2, f of x is equal to x cubed minus 2x minus 1. The answer is no, it is not a quadratic function because it is a third-degree polynomial. Number 3, f of x is equal to 2x. The answer is no, because it has no quadratic term. Number 4, f of x is equal to 2 minus 5x. The answer is also no, this is not a quadratic function because there is no quadratic term. Number 5, f of x is equal to x squared plus 3x minus 4. The answer is yes, it is a quadratic function. Number 6, h of x is equal to 4. The answer is no, it is not a quadratic function because it consists of only the constant term. It has no quadratic term. For number 7, let us first simplify. K of x is equal to quantity x plus 2 raised to the second power minus 5 times quantity x minus 2. Okay, let us expand quantity x plus 2 raised to the second power, square the first term, get twice the product of the two terms. X times 2 is 2x. Twice of it is 4x. And then square the second term. The square of 2 is 4. And then let us apply distributive property. So we have negative 5x plus 10. Let us simplify. X squared plus 4x plus 4 minus 5x plus 10. Let us combine like terms. So we have x squared, 4x, and negative 5x is negative x. 4 plus 10 is positive 14. So we have k of x is equal to x squared minus x plus 14. So it only means that the answer is yes, it is a quadratic function. Let's continue. This time, let's have quadratic function using table of values. A table of values is a graphic organizer or chart that helps you determine two or more points that can be used to create a graph. Let's have an example. Complete the following table of values using the indicated function. The x values are the independent variables while the y values are the dependent variables. In x values, we have negative 3, negative 2, negative 1, 0, 1, 2, and 3. On the other hand, the y values are missing. So let us solve for the y values by substituting x to the given equation. So to find the values, let's substitute the x values to the function f of x is equal to 2x plus 1. So if x is equal to negative 3, the value of y or f of x is negative 5. If x is negative 2, y is equal to negative 3. If x is negative 1, y is equal to negative 2. If x is 0, y is equal to 1. If x is positive 1, y is equal to 3. If x is positive 2, y is equal to 5. And if x is equal to 3, y is equal to 7. Okay, let's continue. So the table of values of f of x is equal to 2x plus 1 is this table of values. The question now is this a quadratic function or not? So how do we determine if a table of values represents a quadratic function or not? To identify a quadratic function from a given set of ordered pairs or table of values, it should have equal differences in x and produce equal second differences in y. Okay. Note that in getting the differences, start from your right to left. So in the given table of values, let us first determine the differences in x. So we will start from our right to left. 3 minus 2 is 1. 2 minus 1, 1. 1 minus 0, 1. 0 minus negative 1 is also positive 1. Negative 1 minus negative 2, positive 1. Negative 2 minus negative 3, positive 1. As you can see, it produces equal differences in x. Let's now proceed to the differences in y. 7 minus 5, 2. 5 minus 3, 2. 3 minus 1, 2. 1 minus negative 2 is positive 3. Negative 2 minus negative 3 is positive 1. Negative 3 minus negative 5 is positive 2. The first differences in y are not equal, but we need the second differences. So to get the second differences, we have 2 minus 2, 0, 2 minus 2, 0, 2 minus 3, negative 1. 3 minus 1 is 2, 1 minus 2 is negative 1. So as you can see, the second differences in y are not the same. From that, we can say that the second differences in y is not equal, therefore, it is not a quadratic function. Let's have another example. Complete the following table of values using g of x is equal to x squared plus 2x minus 1. So the values of x are negative 3, negative 2, negative 1, 0, 1, 2, and 3. So we will substitute these values in the function g of x is equal to x squared plus 2x minus 1 in order to find the values of y. If x is equal to negative 3, y is equal to positive 2. If x is negative 2, y is negative 1. If x is negative 1, y is equal to negative 2. If x is 0, y is negative 1. If x is 1, y is equal to 2. If x is positive 2, y is equal to 7. And if x is positive 3, y is equal to 14. Okay, so this is now the table of values of g of x is equal to x squared plus 2x minus 1. So the question now is, does it represent a quadratic function or not? So remember that to identify a quadratic function from a given set of ordered pairs or table of values, it should have equal differences in x and produce equal second differences in y. And again, in getting the differences, we must start from our right to the left. Okay, let us first determine the differences in x. We have 3 minus 2, 1, 2 minus 1, 1, 1 minus 0, 1. 0 minus negative 1 is also equal to 1. Negative 1 minus negative 2, 1. Negative 2 minus negative 3, that is also equal to 1. So as you can see, it produces equal differences in x. Let's now determine the differences in y. Let's first have the first difference in y. So 14 minus 7, 7. 7 minus 2, 5. 2 minus negative 1 is 3. Negative 1 minus negative 2 is positive 1. Negative 2 minus negative 1 is negative 1. Negative 1 minus 2 is negative 3. Let's determine the second differences in y. 7 minus 5 is 2. 5 minus 3, 2. 3 minus 1, 2. 1 minus negative 1 is also 2. Negative 1 minus negative 3, that is also equal to 2. So as you can see, it produces equal second differences in y. With that, we can say that the table of values represents a quadratic function, since the first differences in x are equal and the second differences in y are also equal. Okay, so let's try to answer this. Identify if each table of values represents a quadratic function or not. Remember that in order to say that a table of values represents a quadratic function, it must produce equal differences in x and equal second differences in y. Okay, let's have the first table of values. 4 minus 3, 1. 3 minus 2, 1. 2 minus 1, 1. 1 minus 0, 1. 0 minus negative 1, 1. Negative 1 minus negative 2 is also positive 1. As you can see, it produces equal differences in x. Let's proceed to y. 9 minus 7 is 2. 7 minus 6 is 1. 6 minus 6, 0. 6 minus 7 is negative 1. 7 minus 9 is negative 2. 9 minus 12 is negative 3. Let's have the second differences in y. 2 minus 1, 1. 1 minus 0, 1. 0 minus negative 1 is positive 1. Negative 1 minus negative 2 is positive 1. Negative 2 minus negative 3 is also positive 1. So since it produces equal differences in x and equal second differences in y, therefore we can say that this table of values represents a quadratic function. Let's have the second one. Get the differences in x. 2 minus 1, 1. 1 minus 0, 1. 0 minus negative 1 is 1. Negative 1 minus negative 2 is also positive 1. So it has equal differences in x. Let's proceed to y. 9 minus 4, 5. 4 minus 1, 3. 1 minus 0, 1. 0 minus 1 is negative 1. Let's have the second differences in y. 5 minus 3, 2. 3 minus 1, 2. 1 minus negative 1, that is also equal to 2. Since the table of values produced equal differences in x and equal second differences in y, therefore we can say that this table of values also represents a quadratic function. Let's have the third one. Negative 8 minus 7. That is equal to negative 15. 7 minus negative 2, that is equal to 9. Negative 2 minus 0 is negative 2. 0 minus negative 2, that is positive 2. As you can see, the differences in x are not equal. Let us still get the differences in y, even though we already know that this table of values does not represent a quadratic function. This is not a quadratic function, since the differences in x are not equal. Let us still solve for the differences in y. 8 minus 4 is 4. 4 minus 20 is negative 16. 20 minus 8 is 12. 8 minus 6 is 2. 4 minus negative 16 is 20. Negative 16 minus 12 is negative 28. 12 minus 2 is 10. So both the differences in x and the second differences in y are not equal. So it is not a quadratic function. Let's have the third one, representing quadratic functions using graph. So another way of representing quadratic function is by using graph. Question: if you are to toss a ball to your friend, what do you think will be the path of the ball? Answer: the path of the ball describes a curved path which is U-shaped, called parabola. The graph of a quadratic function is called parabola. Let's have an example. Graph the given table of values of x and y. Identify if it is a quadratic function or not. Okay, let us plot the points in the Cartesian plane. First, we have negative 3, negative 5. Here is negative 3, negative 5. Next, we have negative 2, negative 3. Next, we have negative 1, negative 2. Next, 0, 1. Next, 1, 3. Next, we have 2, 5. And then for the last one, we have 3, 7. Okay, let us connect the points. So as you can see, the graph is a straight line. Therefore, it is a linear function and not a quadratic function. Let's have another example. Graph the given table of values of x and y. So we will plot the points in the Cartesian plane. First, we have negative 3, positive 9. Next, we have negative 2, positive 4. Next, negative 1, positive 1. Next, 0, 0. Next, 1, 1. And then we have 2, 4. And then last we have 3, 9. So let's connect the points. So with that, what can we say? The graph is a U-shape called parabola. Therefore, it is a quadratic function. So that is how we represent a quadratic function using table of values, graph, and equation. Thank you very much.